Hello everybody, welcome to the algorithm course. In this video, I'm going to discuss the depth-first search. The depth-first search is something like this. From a starting vertex, we go deeper to the respective neighbors until there is no further children for that neighbor. And we need to traverse each vertex exactly once. We store the order of traversing the nodes in one layer in a stack, which follows the last in first out order. And we add the traversed nodes to the stack by following the order of the traversal. Then we pop the stack and traverse the unvisited vertices of that popped vertex. In order to avoid traversing a node twice, we mark the traversed node as visited. And we have to notice one important point. The search result would depend on the order of traversing the neighbors. That means the search result is not unique. Now we go to the pseudocode part. For depth-first search, we have to do some initialization first. We have to create a stack called S, and we have to create a set called visited to store the visited vertices. And then we push the start vertex into the stack, and we also add the start vertex to the visited set. And while the stack is not empty, we do something like this. We pop the stack and make the popped element to become the current vertex, and then I print out the current vertex to indicate the order of our traversal. And then for each neighbor of the current vertex, if the neighbor is not yet visited, I push it to the stack and I add the neighbors to the visited set. So the idea is to traverse each of the neighbors of all the vertices. Now let's take a look at this example. I want to do a depth-first search on this graph, and we start with vertex 0. And the example here would follow the numerical order of the vertices when they are put into the stack. So I need to do initialization first. I need to create a stack called S, and I also need to make a set called visited. And then I will start with the vertex 0. And in this case, I put node 0 into stack S, and I also put node 0 into the set called visited. So we do the popping of the stack so that 0 will become the current vertex, and I want to print out this current vertex 2 to become the first vertex to traverse. And we can see that vertex 0 has neighbors 1, 2, and 3. That means we have to check all the neighbors of 0, and you can see that all the edges connecting 0 to all its neighbors are now in red. Now we check the first element, which is 1, and 1 is not yet in the visited set, and I need to push it to the stack and put 1 into the visited set. Now we check number 2. Number 2 is not yet in the visited set, that's why I need to push it into the stack and I put number 2 into the visited set. Now let's go to node 3. Node 3 is not in the visited set yet. That's why I have to put 3 into the stack and to the visited set. After that, all the neighbors of 0 are all checked. Now we pop the stack to get 3, which becomes the current vertex to handle. And 3 would become the next element to be printed, which refers to my traversing sequence. And 3 has neighbors as 0, 6, and 7. I need to check for all these neighbors of 3. Now, let us check vertex 0. 0 is already in the visited set, and we just do nothing on it. We go to check for another neighbor. Now let's go to vertex 6. Vertex 6 is not in the visited set yet. That's why I need to push it into the stack, and I also need to put number 6 into the visited set. The next node to consider is number 7. Number 7 is not in the visited set yet. That's why I need to put it into the visited set, and I also need to push it into the stack. And after that, all the neighbors of 3 are already checked. Now I want to pop 7 out of the stack, and 7 would become the current vertex to use, and I also print out 7 as another node to traverse. And we can see that 7 has only one neighbor, which is 3, and let us go to check this neighbor. Now 3 is already in the visited set. That means we can do nothing on it. And after that, all the neighbors of 7 are already checked. The next step is to pop the stack so that I can have number 6 coming out. Number 6 would become the current vertex. At the same time, I want to print out number 6 as the next node to traverse. And we can see that 6 has 3 neighbors, which are 2, 3, and 10. And we are going to check for all these neighbors. Now, let us check number 2 first. Number 2 is already in the visited set. That means we do nothing on it. And we just go to check for another neighbor. Now, number 3 is already in the visited set. That's why we do nothing on it. We just go to check for another neighbor of number 6. Now, let's check for another neighbor, which is number 10. Number 10 is not in the visited set yet. That's why I need to push it into the stack, and I also want to put it into this visited set. And after these 2 actions, all the neighbors of 6 are already handled. Then I'm going to pop the stack to get 10 out of the stack. And now 10 would become the current vertex, and I'm also going to print out vertex 10 as my next node to traverse. And we can check that 10 has only one neighbor, which is 6. Now let us go to check for this neighbor. 6 is already in the visited set. That means we do nothing on this node. And after handling node 6, all the neighbors of 10 are already checked. The next step is to do the popping so that 2 will come out of the stack, and 2 would become the current vertex to handle, and I'm also going to print out number 2 as the next node to traverse. And we can check that 2 has 3 neighbors, 0, 1, and 6, and we are going to check for all these neighbors. Now for vertex 0, it is already in the visited set. That means we do nothing on it. We go to check for another neighbor of 2. Now we check number 1. Number 1 is already in the visited set. That means we do nothing on node 1. And we go to check for another neighbor of 2. Now let us handle number 6. Number 6 is also in the visited set already. That's why we do nothing on it. And after that, all the neighbors of 2 are already checked. Now we pop 1 out of the stack so that I can have number 1 being the current vertex. And I also want to print out 1 as the next node to traverse. And for number 1, there are 4 neighbors, 0, 2, 4, and 5. And we are going to check for all these neighbors. For vertex 0, it is already in the visited set. That means we do nothing on it. We can go to another neighbor. For number 2, it is already in the visited set. That means we do nothing on it, and we can go to check for another neighbor. Now, for number 4, it is not in the visited set. That means we have to put it into the stack, and we have to put it into the visited set as well. And for node 5, it is not in the visited set yet. We have to push it into the stack, and I have to put number 5 into the visited set. And after that, all the neighbors of number 1 are already checked. And then I pop the stack so that I have 5 coming out, and 5 would become the current vertex. Of course, I have to print out 5 as the next node to traverse. And for number 5, we have 2 neighbors, 1 and 9. Let us check for all these neighbors. Now for number 1, it is already in the visited set. That's why we do nothing on it. Let us go to check for another neighbor of 5, which is number 9. For number 9, it is not in the visited set yet. That's why I have to put it into the visited set, and I have to push 9 into the stack. After that, all the neighbors of number 5 are already checked. Now let's pop the stack to get 9, and 9 would become the current vertex. And I also want to print out number 9 as the next node to traverse. For our case here, 9 has only one neighbor, which is 5, and we are going to check for this neighbor. Now for number 5, it is already in the visited set. That's why we do nothing on it. And we can see that all the neighbors of number 9 are already checked. After that, we need to pop the stack so that I have 4 coming out. 4 would become the current, And vertex, I would like to print out number 4 as well as the next node to traverse. And for number 4, I have 2 neighbors, which are 1 and 8. Let us check for all these neighbors. For node 1, it is already in the visitor set. That means I do nothing on it, and I go to check for another neighbor of 4, which is 8. Now for number 8, it is not in the visitor set yet. That's why I have to put it into the visitor set, and I have to push it into the stack. After that, all the neighbors of 4 are already checked. Now, let us pop the stack to get 8, and 8 will become the vertex to print out. It is also going to become the current vertex. We can check for the neighbor of 8, which is only 4. 4 is already in the visitor set. That's why we can do nothing on vertex 4. And after this decision, all the neighbors of number 8 are already checked. And now the stack S is already empty. That means the search is now complete. As we know that the order of the traversal is not unique, we can try another way of printing out the sequences. So you can try to give me other sequences following a depth-first search principle and post your answer at the comment section below the video. Thank you for walking through the algorithm with me. If you have any questions about my video, please put your questions at the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.